This is an introduction to acids and bases. So if we compare acids against bases, we can see here that these are some properties of acids. If you were able to taste acids, they would be sour. So some of our acids actually we can eat, while others we cannot. They tend to be liquids and gases. They turn litmus paper red. Litmus paper is an indicator that we can put inside an acid for us to determine whether or not we've got an acidic solution. The pH of acids is less than 7. They range in a scale of 1 to 6. And acids all begin, or a majority of our acids begin with hydrogen, and so that hydrogen is actually the hydrogen ion. We call that hydrogen ion the proton. Acids also donate their hydrogen ion, so there's another characteristic. Here are some examples of some acids. We're very familiar with this one because we've used it in lab a lot. Hydrochloric acid. Some other common acids that you might have not realized are edible acids, such as lemons and vinegar. Vinegar is made up of an acid called acetic acid. So these are our edible acids, which would taste sour. And hydrochloric acid is the one we use in lab, which is not an edible acid. In comparison, we have something called bases. And if we put them side by side and look at them, while acids are sour, bases are bitter, the ones that we can taste. They are mostly solids, and when if you can touch a base, it's very slippery. Litmus paper turns blue for bases, and the pH of bases is less than 7, ranging from 18 to 14 on the pH scale. Bases are usually made up with hydroxides, though not all bases are. Remember, hydroxide is the OH minus ion. And while acids donate the H plus, it's the bases that will accept them. Some examples of bases. Some we've seen in lab are sodium hydroxide. There you go, there's the hydroxide. And two common ones that you know are soap and bleach. Those are bases as well. Okay. All right, so if you remember me saying right here, I talked about acids having the H plus. Let's just really quickly talk about that. Most acids will start with hydrogen, and that hydrogen is a positive ion, H plus. And we like to also call this the proton. It's a nickname, the proton. Okay. Bases, there are two types of bases. There are bases that have hydroxides in them, like sodium hydroxide, calcium hydroxide, lithium hydroxide. And then there's bases that are classified as amines. And those are bases that contain nitrogen. For example, NH3. So these are both examples of bases. The bases that have the hydroxides tend to be stronger than the bases that have amines in them. Okay? All right, now, what happens if I throw an acid into water? Well, let's go ahead and do that. Here's hydrochloric acid, HCl. You should memorize HCl if you don't have it memorized to begin with, right? If I throw this in water, and we can represent that by putting water over the arrow, or we could have just added it as a reactant, okay, what happens? Well, water is made up of H plus and Cl minus, so it dissociates. So it turns into H plus and Cl minus. Okay? All right. How about a base? Well, if you throw this base into water, so again, I'm going to throw water up here, what happens? Well, NaOH is made up of an Na ion, positive, and a hydroxide ion, OH minus. So they dissociate. A new word that we're going to learn is that anytime you throw an acid or a base into water, they dissociate, but the new word is they ionize, which means to turn into their ions. That's what's happening. Okay? Now, a scientist, one of our earlier scientists that decided to define acids and bases, his name was Arrhenius. And he said acids produce H plus ions in aqueous solutions. So let's go back and see if that makes sense. So here's an acid, and I threw it into water. Remember, when things dissolve in water, they're aqueous. Do I get an H plus ion? I do, right there. So that works well. It produces an H plus ion. when when dissolved in water, in aqueous solutions. So this is an acid because it produces the H+. That makes sense. Arrhenius then went on to define a base, and he said bases are substances that when you throw them in water, they produce a hydroxide ion. Let's see. Here's a base. I threw it in water, and I got a hydroxide ion. Great. So this at first seemed like a great definition. Arrhenius's definitions seemed really great. But it turned out that his definitions were not that good because we discovered that there are other types of bases. If you remember, we said that there are some bases that are called amines. And amines do not have hydroxide. So his definition for bases is very limited. It's only good if we're talking about a base that has a hydroxide. So his definition is not the best definition. Another pair of scientists came along, and their names were Bronsted and Lowry. And they came up with a definition called the Bronsted-Lowry acid-base definition. These scientists said, let's say acids are H+ donors. Okay, what does that mean? That means when you throw an acid into water, it has an H+ that it can donate. That works well. And they said bases are H+ acceptors. So when I throw a base into water, it can accept an H+, okay? Meaning it'll take the H+. And that's true, as we'll come to learn. So let's go ahead and memorize both the definitions and know how they differ. So an H+ acceptor is the base, acid is the H+ donor. And then I drew this little picture to kind of maybe let you see. So the acid is going to give up its H+, and the base is going to accept the H+. Okay? All right. That's the end of the video.